Hello, this is Mrs. Ward, and I'm going to go over section 4.1, part 2, and I'm doing the classwork solutions. So let's get started. Um, Numbers 11 through 14 want determine two coterminal angles in radian measure, one positive and one negative for each of the angles that are given. And one of the things they say is there are many correct answers. I'm just going to show you the two that would probably most be seen. So the first angle is I have pi over 6. So in order to find a positive coterminal angle, I'm going to take pi over 6, and I'm going to add one rotation around the unit circle. So I'm just adding another 2 pi and then pi over 6. So I'm going to add 2 pi over 1. I can do common denominators. I can put it in my calculator, however you choose to do it. But when you do that, you end up getting 13 pi over 6. That is one positive coterminal angle. To find a negative coterminal angle, I'm basically going to do the same thing, except for instead of adding 2 pi, I'm going to want to go the other direction. So instead of going up, I'm going to want to go down. So this angle that I'm adding here would be a negative 2 pi. So I'm going to take pi over 6. And I'm going to subtract 2 pi over 1, common denominator, put in my calculator, and I am going to get negative 11 pi over 6. So those are my two coterminal angles. One is positive, one is negative. Doing the next one, part B, I have 2 pi over 3. I want to do one positive, one negative. So to do the positive, I'm going to add 2 pi over 3. I'm going to add 2 pi to 2 pi over 3. That's over 1, so that will end up being 8 pi over 3. To find the negative, I am going to subtract 2 pi. So I'm going to take 2 pi over 3 minus 2 pi over 1. I'm going to get negative 4 pi over 3. So there's my one positive, my one negative. Doing number 12, same directions. I have 7 pi over 6. So to find a positive coterminal angle, I am going to add 2 pi. So I'm going to take 7 pi over 6 plus 2 pi over 1. And I'm going to get 19 pi over 6. Remember, if you are not a fan of fractions, and I can't imagine not being a fan of fractions, but let's say you're not, I'm just taking 7, 6 plus 2 on my calculator. The calculator will do all the work for me, and you will get 19 over 6. Your calculator will leave it as a fraction for you. All you have to do is make sure you put that pi back in. So now I'm doing the negative one, so I'm going to start with the angle that they gave me, which was 7 pi over 6. And I'm going to take 7 pi over 6 and subtract 2 pi. And I'm going to get negative 5 pi over 6. So that's my positive, that's my negative. Doing the next one, I have 5 pi over 4, add 2 pi. So 5 pi over 4 plus 2 pi. That'll be 13 pi over 4. Then to find the negative 1, I'm going to take 5 pi over 4, subtract 2 pi, and when I do that, I get negative 3 pi over 4. I'm ending up with a positive and a negative. If for some reason I ended up with two positives, two negatives, I'm either going to have to subtract or add again, just to make sure that I get one that's positive and one that's negative. Okay, in exercises 15 through 20, they want you to find the complement and the supplement. The complement, remember, are two angles that add up to 90 degrees. So a visual representation of what you're doing is you have this angle pi over 3. This is pi over 3. You're trying to find this angle here. You're trying to find this angle here that when I add them together, pi over 3, so I'm taking pi over 3 plus some angle, and that's going to give me 90 degrees or pi over 2. So in order to solve that, you're going to take pi over 2 and you're going to subtract pi over 3. So you're either changing them with a common denominator, which in this case would be 6, or you're putting in your calculators 1/2 minus 1/3. Either way you do it, you end up with pi over 6. Well, actually, that's a lie. If you did it in your calculator, you did 1/2 minus 1/3, your calculator is going to give you the answer of 1/6. You're just going to have to remember to put that pi there. So that's my complement. And I believe it asks for the supplement too. The supplement, it does. The supplement are two angles that add up to 180. So the visual for that is you take you have this pi over 3. Here's my pi over 3 again. And then I want to add it to some angle, this angle here, that when I add them together, I get pi, which would be 180 degrees. That's another alternative too that I'm not even going to mention. So here I'm going to say pi over 3 plus some angle is equal to pi. I'm going to take pi minus pi over 3, and I'm going to get 2 pi over 3. On my calculator, this pi I would just think of as 1 minus 1/3, and it's going to give me 2/3. Have to remember to put the pi there. Okay, number 16, I have 3 pi over 4. If I do my visual, it's going to give me a hint right off the bat that I'm going to have problems. So 3 pi over 4 is more than 1/2. So 3 pi over 4 is this angle right here. Well, to find the complement, you want an angle that when I add them together, two positive angles that when I add them together, I'm going to get pi over 2. Well, seeing how this is more, then that's not going to work. But if I did it the other way, if I didn't know that, didn't draw a picture, my formula is taking pi over 2 minus 3 pi over 4 to see that I get, and when I do this on my calculator or in my head, I'm going to get negative pi over 4. Well, that's not a positive angle, which means that there is no complement. So I cannot find a complementary angle because it's larger than 90 degrees, so I cannot find another positive angle that I can add to it that would be 90 degrees. Now to find the supplement, I want to have two angles that add up to 180, so I can see that I can find this angle here. So this is pi, so I'm going to take pi minus 3 pi over 4, and I end up with pi over 4. So that is my supplement. So it is possible not to have a complement. It is possible not to have a supplement. If this original angle is more than 180 degrees or more than pi, then I'm not going to have a supplement either. Okay, determine two coterminal angles in degree measure, one positive, one negative for each of the angles. So this is the same thing that I did in the first example, except for to find two coterminal angles. Coterminal means that they have the same terminal side, which means they end up at the same place. The only way that you can end up in the same place is if you add or subtract a whole lap around the unit circle. Since these are in degrees, my whole lap around the unit circle is going to be 360 degrees. So I'm going to take 114 plus 360 degrees, and when I do that, I get 474 degrees. And then to find a negative, I'm going to take 114 degrees and I'm going to subtract 360 degrees. And when I do that, I get, oh my, I got to think, boy, I hope I don't mess this up, negative 246 degrees. I think we're going to pause and make sure I did my mental math right before I go on. Whew, I still have math skills. So yes, that does work. So that is going to be my positive, and that is going to be my negative, and I am done with that problem. Part B, I want one positive, one negative. So to find my positive, I'm going to take that negative 390 degrees, and I'm going to add 360 degrees because that's one lap around the unit circle. When I do that on my calculator, I get negative 30 degrees. Well, that's negative. It's not positive. I was hoping it was positive, but it's not. What that means is, as you can see from this picture, I'm more than one lap around the unit circle. So instead of going all the way around and doing this, I could have just done this part, which would have been a negative 30 degrees. So that can be my negative coterminal angle. To find the positive coterminal angle, I'm just going to take that negative 30 degrees, and I'm going to add another lap around the unit circle. And when I do that, I'm going to get 330 degrees. So this one's my negative, this one's my positive. Now I can have multiple answers. Like if I didn't realize at first that when I added 360 degrees, that was going to give me a negative. If I didn't realize that, you might have taken negative 390 degrees and subtracted 360 degrees. And when you do that, you're going to get negative 750 degrees. And that is also an acceptable answer. That is not wrong. That's why the directions say there are multiple answers, and any of those answers would be correct. Okay, find, if possible, the complement and supplement. So this one just was 24. That you didn't have to do 36, but I want to point something out. So to find the complement, instead of doing pi over 2, I'm going to do 90 degrees. So I'm going to take 90 degrees minus 24 degrees. And when I do that, I end up with 66 degrees. That's my complement. To find my supplement, I take 180 degrees, subtract 24 degrees, And when I do that, I get 156 degrees. That's my supplement. I just wanted to point out on 129 degrees is more than 90 degrees. So this one, you're not going to have a complement, no complement. You will have a supplement, but not a complement. Okay, rewrite each angle and radian measure as a multiple of pi. So remember, we're using that conversion of pi when I draw my unit circle and 180 degrees. And since this is 30 degrees, the degree symbol's on top. So to use this, I'm going to put the 180, so that degree symbol will simplify and the pi will be left in the numerator. When I go to do this problem, the degrees will simplify, that unit of measurement will simplify. I'm going to leave this pi here. So I'm going to start off with 30 pi over 180, which will end up being pi over 6. If you're not a fan of fractions, you're just taking 30 over 180 on your calculator. It'll give you the 1/6. You just have to make sure that you put the pi in there. Rewrite each angle in degree measure. So now I have -4 pi. So I'm doing the same conversion. So I have -4 pi, understood to be over 1, using that 180 degrees to pi. Notice that I put the 180 on the numerator this time, and the reason why I did that is I want my units to cross out. So I want the pi's to cross out. And when I do that, I am going to multiply by 4 and get -720 degrees, because that's the unit of measurement that I'm left with. Okay, convert the angle measure from degrees to radians. So now this one's a decimal. Oh no, this one's not. You have to do 115. So I'm going to do 115 degrees over 1. Again, pi over 180, but I'm putting the 180 degrees in the denominator so that the symbol of the degree symbol will simplify. So that tells me which way I'm going to do it. So the degree symbol is simplifying. And when I do that, I'm going to be left with that unit of pi. So I start off with 115 over 180. And when I divide that on my calculator, I'm going to get a pause. And when I do that, I get 23 over 36, so I make it 23 pi over 36. This pi is in the numerator, so make sure you put it in the numerator. If I had to do this one, 83.7 degrees, I'm going to just do this one to show you. 83.7 degrees over 1 times pi over 180 degrees. The degree symbols will simplify. So the degree symbol, and you end up with 83.7 pi over 180. And then it wants me to round my answer to 3 decimal places, which I didn't do on either one. So now I'm going to take 83.7. I'm actually going to put in my calculator, and I'm going to have to go back and do the other one too. I'm going to take 83.7 pi on your calculator. And I'm going to divide that by 180 and round that, and I'm going to get approximately, and our calculators may round differently, 1.460. And then going back to this one, when I do 23, and I divide that 23 pi and divide that by 36, I get approximately 2.006. So the next one is a calculator one. You have your calculators out, and you are going to convert this to, right now it's in degrees, minutes, and seconds, and you want to convert it into a degree decimal to 3 decimal places. So I have 85 degrees, 18 minutes, 30 seconds. So to put that in my calculator, I'm going to get my calculator out. I just have it on the calculating page. I am going to hit 85 degrees, so 85. Remember, you're going to go here to find your degree symbol. So 85 degrees, 18 minutes, so 18. Clicking that same button again, believe it has a question mark. You're going to hit that tick mark once. and then 30 degrees. And here's where we run into a little snafu. I am so tempted to hit this symbol, and it should work, but it doesn't, and I don't know why. So I'm going to hit the tick mark, and then I'm going to hit that tick mark again. So I have that. It looks just like the problem on the piece of paper. Exactly like the problem on the piece of paper. Whoopsie, where'd it go? It's here somewhere. 85 degrees, 18 minutes, 30 seconds. Looks exactly like what I have on my calculator. Then I'm going to hit the book, and I'm going to type a D in first. It'll take me down to the D's. And then I'm going to search for degree decimal, which is just the 2 capital D's, DD. And I'm going to hit enter. And this is what I see on my screen, the 85 degrees, 18 minutes, 30 seconds, DD. And I'm going to hit enter. And that changes to 85 degrees, 85.308 would be my final answer, degrees. And then going on to the next one. This one, it wants me to convert to degrees, minutes, seconds. So right now, I'm a degree decimal. I have that decimal in there, and I want to change it into that I'm separated into degrees, minutes, and seconds. So I'm going to get out my calculator again. I'm going to type in negative 345. Whoopsie. I got the answer in there somehow. Back it up. So negative 345. Okay. Oh, you know why? Duh. Why didn't anyone tell me? Oh, because I'm in a room by myself. Okay. Hit that negative sign. Okay. If you were yelling at the screen, now you know I know what I'm doing. So negative 3.512. I'm going to hit that book again. Now I want degrees, minutes, seconds. I'm already in the D's. My calculator remembered that. So I'm just going to look for DMS. Looking patiently for DMS. That stands for degrees, minutes, seconds. And when I hit enter, it'll say that negative 345.12, negative to DMS, hit enter again, and that's not right. Pause. Okay, that was a great teaching moment. I forgot to put the degree symbol in. See that little degree symbol? So when you do this problem, you have to tell your calculator that you're not already in radians, because if I look here, my calculator is set to the radians mode. So this thinks I mean negative 345.12 radians and not degrees. So to give you a general gist, negative 345 would be, oh my gosh, like 5 laps around the circle, where negative 345 is only a lap and a partial. So I have to remember to put the degree symbol. So I'm going to type it in so you can see how I do it. Here's that negative sign. I'm not going to make that mistake again. So I do negative 345. I don't know why there's a 6 there. 345.12. Hit that degree. And now change it to hit the book. It should be on the DMS again. So you're just going to hit enter and hit enter again. And now this negative 345 degrees, that should stay the same. Your degrees aren't going to change the same. That 0.12 is going to be changed to the 7 minutes and 12 seconds. That's how when I saw this answer, I knew I was nowhere close. I knew I made a huge mistake. But hey, you learned from my mistakes, so good for us. Moving on. Moving on. All right, so this one wants us to find the angle in radians. So you are going to use that formula, the S is equal to R times theta. So let me get to the board without dropping the microphone. So it wants me to find the angle. So it's already telling me that I'm finding my angle. So in a way, it's giving me a huge hint. It tells me that this 5 and this 6 cannot be the angle, because that's what I'm looking for. So the radius is going to be this 5 centimeters. And the angle length is going to be that 6. And to find theta, I'm just going to divide both sides by 5. And so I'm going to get 6/5 is equal to my angle measurement. So to do, I don't have to do 72, but I would do the same thing for 72 as well. Okay, the next one, it says find the radian measure of the central angle of a circle of radius r that intercepts the arc length s. So you're still using that same formula, r, our s is equal to r times theta. and Mrs. Kelm likes a triangle, same thing. So then this one is telling me my radius is 15 inches. It's telling me my arc length is 8, and it wants me to find the central angle. So again, I'm dividing both sides by 15, so I have 8/15 is equal to theta. Okay, same formula. S is equal to R times theta. It says find the length of the arc of a circle of radius r intercepted by the central angle theta. So it's giving me my radius of 14. It's telling me that I'm looking for the arc length, which is that S, and the theta says 180 degrees. But here's the problem. This must be in radians. In order for this to work, this must be in radians, which means I have to take this 180 degrees, and I have to change that to radians. You should know it, but if you didn't, you're going to use the conversion factor of 180 degrees to pi, and then I can see here that these are both going to simplify. So I am going to be left with just pi. So my angle is just going to be pi, so this theta will be pi, so my arc length is going to be 14 pi. 14 pi inches to be technical. Let's be technical. And that's it. That's all we have to do. So I hope this helps, and we will see you next time. Thanks for listening.